Assalamualaikum and hi to my students. Welcome to the video lecture, Chapter Proof Techniques, Sub-Chapter Mathematical Induction. Imagine if you are requested to add these numbers up until 100. What will be equal to? 200 years ago, approximately, there is a young mathematician known as Carl Friedrich Gauss. He found out if we add up 1 with 100, 2 plus 99, 3 plus 98, this one equals to 101. And you do this up until 50 times. Therefore, there will be 50 times 101, which is equivalent to 50. What if I tell you there is another way to add up the sum of positive integers, also known as natural numbers, up until a very large integer? Actually, the summation of 1 plus 2 plus 3 up until a very large natural number is just n plus 1 over 2. Suppose we already get this formula. How can we sure that it can be used? For example, in the problem of Gauss just now, up until 100. And this one, n equals to 100. According to this formula, it will be 100 times 101 over 2, which is equivalent to 50 as well. So Gauss is right. And how to ensure that this formula on the right hand side is correct? The idea of mathematical induction is that suppose by using analogy we have the first ladder. Suppose this is the first ladder. If we can step on the first ladder, we can actually step at the kth step, and after k is k plus 1. The first step, we must try to prove that the first step can be actually stepped. We assume that the step of k can be stepped on, and we try to prove the step of k plus 1 is correct. Therefore, we assume that it can be arrive up until to the top of the ladder. There are actually 3 general steps if we want to exclude conclusion as step, as any proving should have conclusion. It is mandatory. In short, I would like to iterate that there are 3 major steps of mathematical induction. The first one is we need to prove the first base case, we call as n0, is true. The second one, we need to just assume that when n equals to k, or the kth step, is true. And the last one is we try to prove the case of n equals to k plus 1 is true. We need to always use assumption 2. Use assumption from step 2 to prove the third step. The common mistake by the students, given by any question, they always neglect to use the assumption of step 2. If you don't use assumption from step 2, then you do it wrongly. Now let's look at the example. example 1, which is the sum of Gauss just now, like what Gauss used to, up until n is given by n plus 1 over 2. And do notice that we must always also try to show what is the domain of n. For this case, they use n is the natural number or positive integer, or you can say n larger than or equal to 1. First, identify which is the base case. The first base case is we read from here, or you can read it from the left, but it is advisable for you to start with the first element in the domain. It will be much easier for other questions as well. The first positive integer is 1. Therefore, the first step, we need to prove the first base case, which is in this case is 1, is true. In equality kind of question, there is a left hand side case. This is the whole left hand side and the right hand side. You must prove that the left hand side is equal to the right hand side. The first case on the left hand side is actually the sum of 1 until 1. So we can get left hand side directly, which is 1. For the right hand side, you need to put into the formula. It will become 1 plus 1 over 2. It sums up to 1 times 2 over 2, which is equivalent to 1. The conclusion for the first step is that left hand side is equal to right hand side for the case of p n not equals to 1. As your conclusion, you can say that p n not equals to 1 is true. We are not finished yet because the mathematical induction consists of 3 steps. We proceed to the next step, which is the second one. We need to assume the case when n equals to k is true. You actually need to believe that the summation 1 plus 2 plus 3, when n equals to k, you add up until k, where k is an unknown natural number, which is equivalent to the right hand side will be k plus 1 over 2. That's it. And how to use assumption number 3? We write down first, we need to prove the case of n equals to k plus 1 is true. Just like now, previously 1 plus 2 plus 3, eventually you will arrive at k first. Then after k is k plus 1. This is for the left hand side. The right hand side, it will be from the top is k, you compare with the previous step, and the bottom one becomes k plus 1. K, you replace it, you substitute it with k plus 1, it will become k plus 1 here, and you add up plus 1 over 2. And independently, you need to show what is your left hand side and what is your right hand side. It doesn't matter where you start, as long it can show that it will be equal at the end. Suppose I want to start at the right hand side first, because this is much easier to see for you guys. It will be equal to k plus 1 and this k plus 2 over 2. For the left hand side case, how to use assumption 2? We believe that 1 up until k, excluding k plus 1, is k plus 1 over 2, again from assumption 2. You still need to add up one more, k plus 1 here. It will be k plus 1. If you see this right now, the left hand side is not actually really the same as the right hand side. Therefore, you need to proceed with some algebra manipulation. Try to expand it, or you can use factorization technique, not prime factorization, a simple algebra factorization, in order for you to see that it will be equal or not at the end. I will use k plus 1 plus 2k plus 1 over 2. I make the denominator the same. Next, it can be seen already that it has k plus 1 as the common factor. I put k plus 1, this one will be k plus 2 over 2. Right now, the left hand side is equal to right hand side for the case of p n equals to k plus 1. As my conclusion, p n equals to k plus 1 is true. The grand conclusion from step 1 up until the step 3, what you actually has done is that by using the principle of mathematical induction, or you can just say by using math induction, we just prove that the sum of 1 plus 2 plus 3 up until n is actually can be confirmed to be true as n plus 1 over 2 for every or for all n which is a positive integer. Before I proceed with what we can use after we know this fact, is that I want to highlight this section. The left hand side at the end equals to k plus 1. Some of you cannot get this directly in terms of factorization. Sometimes the student might try to expand it. For example, you put k squared plus k plus 2k plus 2 over 2. Still not the same, but if you factorize the numerator, we simplify first, it will become k squared plus 3k plus 2 over 2, which actually at the end it will be k plus 1, k plus 2 over 2. You can also use this kind of expansion, and some of my students are really not that good at factorization. That's okay, because actually you can try to expand this right hand side here. K squared plus 3k plus 2 over 2. You can also show this form to be similar with the bottom form, as long as you manage to show by using a correct mathematical steps that it can obtain the same algebra representation. Let's try to look after we finish proving that by using mathematical induction, the sum of positive integer is equivalent to n times n plus 1 over 2. How to use this formula is quite simple. Suppose I ask you to sum up 1 plus 2 plus 3 up until 2020, for example. What will be it equal to? As we have already know the fact of is that it can be equal to n plus 1 over 2, it's really important for you to find what is the value of n first. The value of n in this summation is 20. Therefore, if you want to put at the formula, you substitute at this formula on the right hand side. Over 2 is equivalent to 2020 times 2020 plus 1 over 2. It becomes 2020 times 2021 over 2. And then you put it in the calculator for this one for me. Put it into a single digit and you will get the answer very quickly. The usage of this knowledge, by knowing this fact, you can actually shorten the step. Previously, you need to add, for example, in the calculator 1, and then you add 2, and then you add 3. You need to do this repeatedly until the value of 2020. But for now, after we manage to prove the Gauss-Trick formula is right, it's very simple. You just put in the calculator, maybe perhaps you put in the 2020 times 2021 over 2, and it can be done very much faster. Only you plus one time, multiple, and then you divide it. So 3 steps as compared to 2020 steps. Actually, it's 2019 steps, 2019's time. I would like to show another example which is not in the question of exercise 4, but it's really important on how the application of n later, it will be different from the previous one. It is a summation of even numbers, 2 plus 4 plus 6 up until 2n. It's actually equivalent to n plus 1 for every n which is positive integer. In this kind of question, some students find out will have a problem regarding what is the first base case or n naught. You can rely at this n here, but for the students who show this n, they thought that n naught is equivalent to 2. How to read this is that the first n naught is actually the first element of positive integer. Do not read at this part, read at this one, it's better. This is what I meant. We start with step 1 first. What is the first n naught? Is still 1, because 1 is the first element of positive integer. But if you try to put in this case 2n, where 2n naught here, 2 times 1, it will be 2. Therefore, if we put it in the left hand side or right hand side, you can either put 2 times 1 equals to 2 as your left hand side. That will be your calculation to find the first left hand side by using the n0, which is equivalent to 1. It is not 2. By using n0 equals to 1, then you put into 2 times n, then it will be 2. 2 will be your left hand side. Right hand side is the same as always. It doesn't change. n0 is still equivalent to 1. You put into the formula, it will be equivalent to 1 times 1 plus 1 1 times 2, and the right hand side is 2. Don't forget to put the conclusion at each step. Left hand side is equal to right hand side for P n0 equals to 1, because 2 is equivalent to 2. The first base case n0 equals to 1 is true. Be careful when to choose which one is the n0. The safest one is always look at the domain. Step number 2, you need to just assume that the summation from 2 plus 4 plus 6 up until we need to assume that n equals to k is true. Plus 4 plus 6 up until plus 2k will be k plus 1. That's all. We proceed with the step 3. We need to prove that n equals to k plus 1 is true. Always remember, by using the second step, 2 plus 4 plus 6, you will first arrive at 2k. And the case after 2k is 2 times k plus 1. Some of the common mistake by the students, they actually write here plus 2k plus 1. They just substitute, put k plus 1 into the practice. And again, the red color one is not the same as the top black color one. It will be different, the value, when you try to expand the black color. Be careful when you want to substitute k with k plus 1. What will be your right hand side? You compare with step 2. The step 2 at the assumption 2 is k. You can read like this, k plus 1. You add up here, it will be k plus 1 plus 1, close. And do this independently. You can always start with right hand side or left hand side, up to you. But for this lecture purpose, for easier understanding, you can see directly that right hand side is equivalent to k plus 1, k plus 2. And the left hand side, as we believe that the summation from 2 up until 2k will be k plus 1, you add up this one plus 2k plus 1, And some of you can see this directly, that this left hand side has already can be factorized to k plus 1, k plus 2. However, for the students who cannot do this directly, you can try to do expansion instead. It will be like this: k squared plus k plus 2k plus 1, 2k plus 2 is equivalent to k squared plus 3k plus 2. For this right hand side, it's not similar in terms of the representation. You can also expand the right hand side, and it can be found that can also be expanded to k squared plus 2k plus k. It will be 3k plus 2. There it will be similar, as long as you show by a correct mathematical step that it can be similar, be it factorization or expansion. Then it still show the same conclusion, which is that right hand side is equivalent to left hand side for pk plus 1, n equals to k plus 1, doesn't matter. As my conclusion is that this Pn equals to k plus 1 is true by using math induction. What I proved to you just now is that the summation of 2 plus 4 up until 2n is equivalent to n plus 1. Okay, still can be seen. Okay, this time we try to apply, after we manage to prove that this formula is true for every n which is a positive integer. Now to use in the context of the example of the application, 2 plus 4 plus 6, for example, is I want to add up until 2020, what will it be? Some of the students think that the value of n is 2020. This is not true. N represent the element, or you can also say the term, the number of term. 2020 is not the 2020th element. This is how you can find the value of n. You try to equate this 2n at the top with 2020. You let 2n equals to 2020. Actually, the value of n is 1010. And we put into the formula on the right hand side here. It is when n equals to 1010, 1000 times 1000, 1010 plus 1 is equivalent to 110, 110, 110, 11. Put into the calculator, you can find the actual value in the value of single integer. I will do the other exercise if you request to, except question 3, because that is your assignment question, I suppose. But I can demonstrate to you, for example, number 1, number 2, and number 4 in the actual video online lecture, real-time lecture for my session. For Miss Anis session, ask Miss Anis as well. I think that sums up this video lecture for mathematical induction and how to apply the formula into the practice. Thank you.